Morning, my fabulous chemistry faithful. Video number 9. Today we are going to draw board diagrams. Board diagrams are like that planetary model, and they give us a map of the entire atom. Next lecture we will do just Lewis dots, which will be a shortcut. Okay, so we're going to start by drawing a small circle as the nucleus, and I'm just going to put a P equals N equals inside that circle. Okay. And then I'm going to draw a ring around the nucleus for each energy level in that electron configuration. We just did a lecture on electron configurations, so now we know how to read those. I'm going to draw a dot on for each electron in each level of the electron configuration. And note that the ring closest to the nucleus is the first number in the electron configuration. We're going to start inside and work out. Okay. And we're right to it, right? So let me just check. Yep. Nothing's going to come up here. We're just going to go ahead and do this. So let me grab my handy dandy reference table. Sodium, if you didn't know, is Na. So I'll put that up on there. Sodium is Na. And as I look, Na is number 11, and it has a 281 electron configuration. I don't know if you can see that, but it's there. So 281 is my electron configuration. I know that the atomic number is 11, so I'm going to say P equals 11. And then real quick in my head, I know the mass is 23, so 23 minus 11 is 12 neutrons. And then I'm going to draw a circle around that. Now, I'm going to color code these first few because the most common error is for a student to use that circle that is the nucleus and start putting electrons on that. And electrons do not reside in the nucleus. Okay, so I count up the number of rings I need because I have 1, 2, 3 energy levels. So now I need 1, 2, 3 rings around my atom. And then in the first energy level closest to the nucleus, I'm always going to put 2. So 1, 2. Nice rule. Doesn't matter where on the circle I put them. I can put them right next to each other if I really want. Okay. What I end up doing is generally putting the electrons where the loop meets to try and keep it neater. I put the first electron there. So in the second energy level, I need 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then the last one, I need 1. And my number of protons is 11. Okay, good. All right, fluorine all the way over here. This is element number 9. Fluorine is F. It has an electron configuration of 2-7. It has 9 protons. It has a mass of 19. I got to round that up, so it has 10 neutrons. So I'm going to use that to label my P equals 9, N equals 10. I'm going to use that to label my nucleus is what I meant to finish with. I'm going to use a different color, 1, 2 for the energy levels. 1, 2. First one gets 2. Second one gets 7. 1, 2, 3, 4, 5, 6, 7. These things are really not going to get any more complicated than that. And notice it is a complete map of everything in the atom as far as we are concerned in Regents chemistry. I can have to draw an ion. So again, I have sodium and fluorine. Sodium again is Na. And sodium has 11 protons and 12 neutrons, so that isn't going to change. Okay, for an ion, because ions are electron games, it was 281. Now, because it's an ion and because it's a +1 ion, we need to be able to make that jump from the work we've done previous to that, previous to this in the unit, is a +1 ion is actually losing an electron. +1 ions mean protons are winning. If protons are winning, then I must have lost electrons. I cannot gain or lose protons. So why is it not erasing? Okay, so I'm going to put those things back up that I wanted. So 2, 8, and so instead of 1, I'm going to lose that 1. So its electron configuration now becomes 2, 8. Again, in my nucleus, I have, sorry, my nose is itchy, N equals 12. There's my nucleus. Now I only have 2 rings instead of 3 though. So that's important. And you're going to get points if you have the right ones in. So 2 in the first, 8 in the second. Right where I like to put that first dot where the ring hooks, so it looks neater. 3, 4, 5, 6, 7, 8. And then I want to bring that charge down to put a +1 in the corner. I always want to have a charge when I have an ion. Okay. Same thing with fluorine. Remember, it's F. It was 2, 7. Well, -1 ions now means electrons are winning the game. So hence I gained an electron. So this is going to become 2, 8. Now I haven't said this formally, but so I'm going to say it now. When I add and lose electrons, I always lose them from what's called the valence shell or the outside shell. I will never gain or lose them from the inside. Okay, so I'm never going to put that electron here. I'm always going to put it on the outside or last number. I'm either going to gain or lose from there because that's the outside part of the atom. That's where those things are going to happen. Fluorine's protons is 9. Neutrons is still 10. That doesn't change. So let me draw my nucleus. 9 and 10. And there's my nucleus. I'm going to draw now 2 rings. 1, 2. First ring has 2 electrons. Second ring has 8. -1 charge. Bring that with me because it's an ion. Good? All right, I think I got a few more quick examples. I'm just going to do a few extra examples so that on a lesson like this, hopefully you can get right to the practice and do it all by yourself. Okay? Other than having to deal with these things from the words, which is probably the toughest part actually for you guys, not knowing the atoms as well as you might like to, but you're going to get the hang of it. So hydrogen is element H. It has an electron configuration of 1. It has 1 proton and no neutrons because it has a mass of 1. So I'm going to say P equals 1, N equals 0. And it only has 1 energy level with 1 electron. Piece of cake. Helium atom. Helium is He. Its electron configuration is 2. It has 2 protons and 2 neutrons because it has a mass of 4. So P equals 2, N equals 2. There's my nucleus. Here is my electron configuration. 1 ring, 2 electrons. Those are the 2 simplest atoms in existence. Okay? Lithium and oxygen. Here we go. Lithium is Li. Lithium's electron configuration is 2, 1. He has 3 protons, has a mass of 7, so he has 4 neutrons. I know I'm doing that fast, but we've gone over this quite a bit, and so I'm expecting you to hopefully get a little bit more fluent with that piece. I have 2 energy levels, so 2 rings. First one gets 2. That was a bad one, but it happens. And there we go. 2, 1. There we go. Moving right on to oxygen. Oxygen is O. Electron configuration is 2, 6. He has 8 protons, a mass of 16, so 8 neutrons. P equals 8. N equals 8. There's my nucleus. And I have 1, 2 energy levels. That means 1, 2 rings. First ring gets 2. Second ring gets 6. And there is oxygen. I think we have 2 more and we'll be done. Ions. So lithium plus 1 ion. Okay, so lithium again is Li. Lithium electron configuration is 2-1. But this is a lithium plus 1 ion. Protons are winning. If protons are winning, I lost electrons. So I'm going to lose this 1 electron, and my electron configuration now is going to become just 2. My protons and neutrons stay the same. Protons are 3, neutrons is 4, gives me a total mass of 7. And now I really only have this 1 energy level. So I'm going to go ahead and draw my 2 electrons, bring down my +1 charge, and that one's done. And then a chlorine -1. I got a Cl as chlorine. Chlorine is 2, 8, 7. but he's a -1 ion. So electrons are winning. If electrons are winning, I gained an electron. I have to put it in the valence shell. So my electron configuration now is going to become 2, 8, 8. Let's draw it up now. Oh wait, chlorine has 17 protons. He has a mass of 35. That one I round down. So he has 18 neutrons. And this is why we don't draw these with pluses anymore, because it would be really hard to draw this many pluses and minuses. So we just list them by number. There's my nucleus. I need 1, 2, 3 energy levels. 1, 2 in the first, 8 in the second, and 8 in the third. Bring down my charge of -1, and with that, we are done. I think that is our last one. Boom, that's it. We got it. So now you can draw Bohr diagrams. Will you have to be able to do them on the test? Absolutely. Do your practice, check your work, and let's get on with Lewis dots are next. Wait, sorry, one more time.